All right, so we're still talking about transformation of graphs, but today we're going to talk about the other types, reflection, compression, and stretching. So let's start with reflection. Reflection through the x-axis. So here, if we look at this example, this is the x-axis. So reflection through the x-axis just takes this graph and flips it over the x-axis. So it's kind of like a mirror image on the other side. All right, so it says the graph of negative f of x is obtained by reflecting the graph of f of x through the x-axis. So just by looking at this, can you tell me what is changing here? Are the y values changing or are the x value changing? And don't let all of this x-axis stuff mess you up. All right, what is literally happening here? You're taking negative of the function. Remember, the function is the y-axis, so you're taking the negative of the y values. So here, we're actually changing the y values. So the x will stay the same. All right, so let's look at this example. So for the graph of f of x shown below, sketch the graph of y equals negative f of x. So what does this tell us to do? This tells us to make y negative. All right, so we're not going to do anything to the x values. We're just going to make the y values negative. All right, so the way I like to do this is to choose strategic points first and make an xy table of those points. All right, so I think the end points and this middle point up here are good points to look at, and we're just going to transform those points, and that's what's going to let us draw our new graph. All right, so this point is negative 1, 2, 2, 4, and 3, 3. Okay, I'm just going to put an arrow here because I'm transforming it. So the next step is to actually transform those points. Again, we're only changing the y values, so we're going to use the exact same x values. But the thing we're going to do, y is negative f of x, so we're just going to make these y values negative. And then plot those points. All right, and then we connect those dots. And we have our new transformed graph. So when you do these problems, it's so good to ask yourself, did the graph do what we expected it to do? All right, so when we put the negative in front of the function, this should be a reflection over the x-axis. So this should be like a mirror image where the x-axis is like the mirror. So these should look exactly the same, mirror images. Yes, so that means what happened is what was expected, so we did this correctly. Okay, now let's talk about vertical compression and stretching. So we're either squeezing the graph together or stretching it out. All right, so let's say c is a positive number, and if c is greater than 1, then we have y equals c of f of x. It's obtained by stretching the graph of f of x vertically by a factor of c. And if c is between 0 and 1, then we're going to be compressing it by a factor of 1 over c, which sounds more complicated than what's actually happening. So first, let's start with what we're doing. This c of f of x, how is it changing the graph from f of x? Is it changing the x value or the y value? Well, you're multiplying c by all of y, so we're changing y. So nothing is going to happen to x at all, only y will be changed here. So let's look at an example. So this one we're just going to transform one point. So if the point 3, -1 is on the graph of f of x, find the corresponding point on the graph of, for A, 7 times f of x, and for B, 1/4 times f of x. All right, so how is this changing? So our original is f of x. What is this 7 going to do to our point? Well, it's just multiplying by the y value. So we're just going to multiply y by 7. That's all this does. And here, what is this 1/4 doing? Well, it's multiplying by the y value. So we're going to multiply y by 1/4. Alright, so nothing's happening with x at all here. So let's look at the problem. Alright, so again, we're given this point 3, -1, and we want to transform it. So for A, we're going to transform it and see what this point will go to on the graph of 7 times f of x. Well, like I mentioned, x doesn't change, but for y, we have to multiply it by 7. So our new point is 3, -7. Okay, let's look at B. Again, our point is 3, -1. We're transforming the point that's on f of x to a point that's on 1/4 of f of x. X doesn't change, but for y we have to multiply it by 1/4. So on our new graph, that point corresponds to 3, -1/4.